Hi, today I would like to talk to you about the first of the solid principles of software design, the single responsibility principle, or SRP for short. Out of all the solid principles, the SRP is perhaps the least well understood. This is likely because the name itself is a bit misleading. It's easy for programmers to hear single responsibility and assume that it means each module or function should do just one thing. But that's not quite accurate. The true essence of the SRP is that a module, whether that's a class, a function, or even a larger component, should have one and only one reason to change. In other words, a module should be responsible to a single actor, be that a user, a stakeholder, or a specific group with a particular set of requirements. So what is a module? A module is a cohesive set of functions and data structures. The word cohesive here implies the SRP. The cohesion is the force that binds together the code responsible for a single actor. Let's look at an example to illustrate this. Imagine a course class in a course management application. This class has three methods: calculate GPA, calculate fees, and save. On the surface, this might seem reasonable, but in reality, this class violates the SRP. The calculate GPA method is specified by the exam staff reporting to the exam director. The calculate fees method is used by the finance staff reporting to the finance director. And the save method is specified by the database administrators reporting to the IT director. By putting all of these methods in a single course class, we have coupled the code that different actors depend on. This can lead to all sorts of problems down the line. The best way to understand the violations of the SRP is to consider symptoms. The first symptom is the accidental duplication. For example, if the finance team needs to tweak the way credit hours are calculated, that change could inadvertently break grade reports generated by the exam staff. The second symptom is the risky merge. For instance, let's assume a situation that the IT team needs to make a schema change to the course table and the finance team also wants to make a change to the course class. So they both check out the course class, and when they push their commits, a conflict occurs. The next thing they do is a merge commit. Even though there are enough tools nowadays to resolve merge conflicts in a clever manner, I don't need to mention that each merge brings its own unexpected outcomes to other teams. Not only the finance team and the IT team who were involved with the merge, but the exam team could also be impacted by this change. So what are the solutions we have for the violations of the SRP? The first solution, as prescribed by the SRP, is to separate the code that different actors depend on into different modules. We might have a course finance class, a course grade class, and a course data class, each responsible to a single actor and unaware of the others. The second solution is to use facade pattern. Here we define a course facade template and provide a blueprint for other classes that want to use course. The facade class is responsible for instantiating and delegating to the classes with the functions. Next, we can define GPA calculator, fees calculator, and course saver classes as derived from the course facade. However, separating classes like this creates a lot of classes and additional code. This is where you need to strike a balance on how much responsibility you want to separate between each actor. But having an understanding of the SRP will give you an indication of the problems that might arise in the long run if you couple code for different actors in a single module. Overall, this separation of concerns not only avoids accidental duplication and risky merges, but it also makes the code more flexible and maintainable in the long run. Each module can evolve independently to meet the needs of its particular stakeholder. The SRP is a deceptively simple principle, but one that has far-reaching implications. It doesn't just apply at the function or class level, it also manifests at the component level as the common closure principle and at the architectural level as the axis of change. Therefore, understanding and applying the SRP is crucial for building software systems that can adapt and grow over time. Thank you.